In this video, we're going to look at section 1.6. This will associate with your My Math Lab assignment number 8. Remember in section 1.2, we talked about functions and the notation for function being f of x, or in this case, g of x. We're going to look at algebra functions in this section. This is the first part of assignment number 8. There will be a second one following this one. We're going to pay particular attention to notation, so that's what I really want you to focus in on in this assignment. You're going to be given two functions. F of x equals x squared minus 3, g of x equals 2x plus 4, and that's what we'll be working with. Now remember, f of x really takes the place of y, so that's like saying y equals. In the first one, you notice that this says f plus g of 5. This does not mean to multiply by 5. This is the same as saying we're going to take function f, add it to function g, and the new name will be f plus g. You will not multiply by 5. There are two ways to work this. So the first I'm going to do is to take function f, which is x squared minus 3, add it to function g, which is 2x plus 1. That gives us x squared plus 2x minus 2. Now, if you'll notice, they gave us a number. Sometimes you'll just have an x, but this time, they gave us a number 5. And we're going to substitute this 5 in place of all of our x's. So we'll have 5 squared plus 2 times 5 minus 2. 25 plus 10 minus 2, or 25 plus 10 is 35, and 35 minus 2 will be 33, and that would be our answer. Now, another way of working this is to actually go in and say, what would f of 5 be? And that would be 5 squared minus 3. And what would g of 5 be? That would be 2 times 5 plus 1. And if you do your multiplication here, g of 5 would be 11, and f of 5 would be 25 minus 3, or 22. And then if you add f plus g, that would be 22 plus 11, which would be 33. Now notice your answer is the same either way. So you take a choice here on which way you want to work this. Looking at the second one, we'll take our function f, which is x squared minus 3, and be very careful here. We're going to subtract 2x plus 1. Now remember, when you subtract, that means we're going to change both of these signs. So that will be negative 2x, negative 1, or x squared minus 2x minus 4. Then when we substitute our negative 1 in, we're going to have 1 plus 2 minus 4, or 3 minus 4, or negative 1. Now remember, there was another way that you could have worked this by substituting each individually, but either way would be fine. Okay, we're going to look now at number 3. Now remember, you have these sheets in your class notes. You can copy every one of these off and go back and listen to this again and work them along with me if you want to. Your sheet looks like this. It's a typed sheet. I have rewritten it in handwritten form, so I have a little more room to work. Use the functions to determine each of the following and state the domain. You're given a new f of x, you're given a new g of x, so let's go. Notice, f plus g means to add. We don't have a number, so we won't be substituting anything in. We'll just strictly substitute f plus g, and that'll be x squared plus 2x, let me go again, x squared, and if we add these two, that'll be minus x minus 4. And that's going to be our final answer for that one. Now when it says to state the domain, if you look at this expression, and remember 1.1, there are no fractions, there are no square roots, so the domain is all real numbers or negative infinity to positive infinity. Number 4, we have f minus g. Order is very important. X squared minus 3x minus g. So x squared minus 3x, change your signs. Descending order would give us x squared minus 5x plus 4. Again, we have no fractions, no square roots, so our domain is all real numbers, or any number at all. In the next one, I just want you to notice that order is important. If I take g first, and I subtract f, I'll change the sign again. Going in descending order, I have negative x squared plus 5x minus 4. Again, my domain, no fractions, no square roots, is all real numbers. Number 6, we'll use the same values for f and g. I want you to notice notation. This raised closed dot, remember, means multiply. Sometimes you'll see it just with the f and g written side by side. Notation for multiply. We'll take f, which is x squared minus 3x, and we'll multiply that by g, which was 2x minus 4. I'm going to use FOIL, so that's going to be 2x cubed. Outside, that'll be minus 4x squared. Inside, minus 6x squared. And last, that'll be positive 12x. Combine like terms. Here, we'll have our negative 10x squared plus 12x. Now again, no fractions, no square roots. Your domain is negative infinity to positive infinity, or all real numbers. This, of course, means to divide. We'll have f on top, which is x squared minus 3x, g in the denominator, which is 2x minus 4. I am going to take out a common factor just to be sure that nothing will divide. And as you notice, nothing will divide in that. So this is my answer. But now I do have a fraction. You notice I had a fraction. And to find the domain of a fraction, this goes back to section 1.2. You take the denominator and set it not equal to 0. And that tells us that x cannot be equal to 2. That's our domain. Now if we write that in interval notation, that means that x can be anything except 2. So that would be negative infinity to 2 with a parenthesis not to include it, and then 2 with a parenthesis to positive infinity would be the domain.